with all the energy. So as soon as we get slides up, I want to speed run you guys through a story. So in 2019, I imagined we'd have AI that was like speaking to a human in the room. And in 2021, I imagined a new kind of programming model for AI that would be based on these robots that can talk to each other. And thank goodness, in 2022, we got the first evidence in the world that this was possible, that we could have human in the room level interactions with AI. And just 2 years later, we had agents everywhere. And that was the beginning of a trend. And now, today, this is actually the world we live in. We have in-loop agents like Claude Code, Codex, Copilot. We now have the out-of-loop revolution that's happening with OpenClaw, and we have the ClawSphere, is what I'm calling it, where claws are, people are imagining and building, and it's opened up to everyone. The barrier to entry has gone down significantly, but there's still a problem. And I think that this is the problem of our time. It turns out that even though we've had so many revolutions in computer science and engineering, we got the internet, we got mobile phones, we're connected all the time, we're in the AI revolution. The languages that our open claws are using are from the 80s. Python and JavaScript is still the #1 and 2 languages in use. We're still using technology that was imagined before we had the connectivity of the internet, or a cell phone, or an iPad, or AI. And so this is a new bottleneck. In order to build a real application, right? So we can build websites really, really well now with the claws, but you can't have Claw build Slack and deploy it to all your friends yet. And the reason we submit is the polyglot problem. You need about 8 languages, 5 frameworks, and 12 services to realize Slack or X or Amazon and actually launch it to all of your friends. And so that's why we're working on Jaseci. It's a stack for AI and us humans to build better, to avoid the polyglot. In order to build a to-do list right now, our OpenClaw has to write all of those lines of code. If it's using JavaScript, React, Python, Fast API, all the good stuff, Supabase, W Supabase, but it's still part of the polyglot. But with Jack and Jaseci, it just takes that to realize the same application. Much easier for a claw. 11x token, less tokens to realize a full stack app. And honestly, this is a barrier that the Anthropics and the OpenAIs don't know that they're hitting yet, but they're close. Because just this year, they've invested to acquire Bun. And OpenAI is acquiring Astral. And these are the toolings for Python and the toolings for JavaScript. They need control to vertically integrate the design of their coding agents, their tooling systems, their models. Co-design is the future of the next tectonic shift. And so we've built a co-designed stack where we design through the entire stack, and it's phenomenal. So here, a fully functional LinkedIn that can scale to millions of users was built with a lovable style experience. And it's full stack ready and scalable. This is a fun video. This isn't actually the real demo because we also tried it with Lovable and nothing worked. It's too hard, right? It's too much polyglot. But what I really want to celebrate today is the wonderful work that the students are doing. So I'm going to talk a little bit about Jack Hacks, which we had 2 weeks ago, 250 students and professionals from all over the country, Harvard, Stanford, ASU, etc., came, converged at University of Michigan, and built 80 different full stack applications. And I want to show you one of them. And then I have one of the upstart CEOs that everyone should be paying attention to, who's building his startup on this stack. But let's see what the winners of the hackathon that we just had 2 weeks built, and I'll talk through it. So this is GraphClaw. This is a new vision for an OpenClaw of the future. So this is fully functional. They did it in 24 hours, hooked into Discord, Telegram, etc. The brains of this claw is written entirely in Jack. And what's phenomenal is there's the dashboard in the claw that is always running with your claw that you can use to see the brains of your claw. And so very soon, you're gonna see that you can interact, customize, change the nature of the claw, see the brains. And here we're looking at actually the brains of the claw. So this is in a graph representation. There's skills, there's tools, everything the claw is capable of. And all of those satellites are interactions that the claw learned from. They built that in 24 hours, and it's open source. And you can use it, you can tweak it. And I'm gonna give just 1 minute to my colleague here, Vatsal, to tell you about what he's doing.
Hey everyone, I'm Vatsal, building a lot of startup stuff and the next YC founder. We're building Amplify, which is an AI-powered system for e-commerce operations. And the idea is to automate all the workflows for brands. Because right now, if you want to list a brand on Amazon, Best Buy, and Shopify, there's a lot of different things you need to get done. And we built this entirely in the Jack stack, saving us almost 9,000 lines in code and using twice the less code compared to a traditional stack. I'm just going to quickly run through this demo. The idea is that brands have to upload their product data sheets onto the platforms, and they have to specify this for each different platform, which takes about 3 to 4 days. But with this platform, we just kind of take the feed and we do all the parsing automatically. So we have like a multi-agent system where we're using the graph, based language that can get the product data, get the SKUs, get the size, the colors, and the agent just runs on the graph. You don't need to have like a database management system. And this has not only helped us develop 2x faster, but also save a lot of time and help brands reduce their return rates. But thank you so much for having us here.
Thank you all.
Thank you, Jaseci and Vatsal. They ripped through that thing in the end, didn't they? And lastly, our final demonstration, Xiangwen Xu, a PhD student at the University of Michigan from China, an autonomous discovery of superconducting materials using Jaseci.